Hello, welcome to Operations Management. In this lecture, I will talk about xbar and R charts. Xbar chart is used for a measurement data where we are interested in measuring the average. The formula for xbar chart would be x double bar A to R bar, where x double bar is the grand mean or average of sample means, and R bar is average of sample ranges, and A2 is A factor from statistical process control tables. So I will give you a statistical process control table and you have to look for A2. For R chart, the upper control limit is given by D4 R bar, and the lower control limit is given by D3 R bar, and the D3 and D4 are again D factors from the statistical process control table. Yeah, so we will try to solve a problem on this and see how we can use these formulas. So here is our question. The time to replace vehicle wiper blades at a service center was monitored using a mean and range chart. 6 samples of n is equal to 20 observations were obtained and the sample means and ranges are computed below. We are given with mean and ranges. The question 1 is, using the factors in statistical process control table, determine the upper and lower limits for mean and range charts. So I will do question A first. So we have, this is part A. So they are asking us to calculate the upper and lower limits. So for X bar chart, the upper control limit and lower control limit are given by the formula X double bar plus or minus A2 R bar. That was our formula. So if we use X double bar minus A2 R bar, this is lower control limit, and if we use X double bar plus A2 R bar, this will be our upper control limit. So to calculate X double bar is the grand mean or the average of sample means. So these are sample means, so we have to take the average of those numbers. So that is 3.06, which is this number, plus 3.15 plus 3.11 plus 3.13 plus 3.06 plus 3.09 divided by 6 is the average of these numbers. So that will be, if we calculate the average of these numbers, we will get X double bar as 3.1. So the next we have to calculate is R bar. So R bar is the average of sample ranges. So I will take the average of these numbers. So that would be 0.42 plus 0.50 plus 0.41 plus 0.46 plus 0.46 plus 0.45 divided by 6. So if you calculate this, you will be getting 0.45 as your range. So now if you see, I wanted to calculate in this formula, I have X double bar, I have R bar, now I need A2. So to calculate A2, we have a statistical process table. So this will come from statistical process control table. So we are looking for, the question says n is equal to 20. So you will go to a statistical process table and look for A2 value at n is equal to 20. So I will go to the statistical process control table, and if you see, the sample size here is the n value, and if you go to 20, so this is 20. I will highlight with different colors. So the A2 value here would be 0.18. So I will go to our Word document, and now A2 is 0.18. So that's our A2. So now we can calculate our lower control limit and upper control limit. So the lower control limit would be x double bar, which is 3.1, minus A2 is 0.18. So that's this is A2, and x double bar is this, and then R bar is 0.45. So this we will get, if we calculate, this will be 0.019. So upper control limit for this would be, now I will do plus instead of minus. So the formula would be x double bar plus A2 R bar. So x double bar is 3.1 plus A2 is 0.18 multiplied by 0.45. So this is going to give us 3.181. So these are our control limits for x bar chart. So x bar chart will have a lower control limit of 3.019 and upper control limit of 3.181. So similarly we can do R chart. So the formula for R chart, if you see, the upper control and lower control limits, they are D4. So upper control limit is D4 R bar and lower control limit is D3 R bar. So lower control limit is D3 R bar, and then upper control limit is D4 R bar. So we have R bar, which is 0.45. We calculated this. So we need D3 and D4. So again we will go to our statistical control process control table and look for D3 and D4 at n is equal to 20. So we are looking for D3 value, which is this. So that would be 0.414. So D3 is 0.414, and then if I go and look for D4, which is 1.586. So this would be 1.586. So if I wanted to calculate lower control limit, which is D3 R bar, so that would be 0.414 multiplied by 0.45. So this is going to be 0.1863, and upper control limit, this is going to be D4 R bar. So that is D4 is 1.586 multiplied by R bar is 0.45, so that is going to be 0.7137. Again, for our X bar R bar chart, maybe R chart, not R bar chart, R chart, the lower control limit would be 0.1863 and the upper control limit would be 0.7137. So this is part A of the question. Now part B of this question, they are asking us, is this process in control? So that is what they are asking us. So we have to plot to identify whether the chart is in control. So firstly I will draw X bar chart. X bar chart. So if you see our X bar chart, our lower control limit is 3.019 and upper control limit is 3.181 and our average, which is represented by X bar, so this is average, X double bar, average of means, so that is, if you go here, that's 3.1, so this is going to be 3.1. Now I will plot these. So I will try to draw a chart here. Suppose I start with 3, so this is 3, this would be 3.05, 3.10, 3.15 and then 3.2. So lower control limit is 3.019, so the line would be something like this. So I will put the samples also, 1, 2, so x-axis is samples, 3, 4, 5, 6, I have 6 samples. So the data set, if you see here, I have 6 samples. So I'm plotting them. So this is lower control limit, which is 3.019, and then I have upper control limit, which is 3.181, so it will be somewhere here. So this is upper control limit, which is 3.181, and then I have X double bar as 3.1, so that will be this. This is X double bar, which is 3.1. So now I will take this data set and try to plot. So our sample 1, if you see, 3.06, so I will try to plot that here. So 3.06 would lie somewhere here, because this is 0.5, so this is sample 1, and then what's the next one is 3.15. so I will go to our sheet. 3.15 is the sample 2, so that will lie here, and then the third one is 3.11, so this is 3.10, so the third one 3.11 would be somewhere here, How about fourth sample? 3.13. So 3.13 would lie somewhere here, and then the fifth one, 3.06. So 3.06 would lie again somewhere here, and then finally 3.09. So 3.09 would lie somewhere here. So if you see, all these sample data are within the upper control and lower control limit. So X bar chart is in control. This is in control. So if it would have been somewhere here like this, then it is out of control. So that is what our process is out of control. So there is no data set outside the upper control limit and lower control limits. So the process is in control. So similarly, we have to draw for R chart. We will look at R chart. So the lower control limit for R chart is 0.1863, and then the upper control limit is 0.7137, and then if you see our data set, so we have data set so we will try to again R bar is 0.45, so I will write R bar also. R bar is 0.45. So again I'm trying to plot this. I will use, so this is point 10, 0.20, 0.30, 0.40, 0.50, 0.60, and then 0.70. And then again I have sample 1, 2, 3, 4, 5, 6. So my lower control limit is 0.18, so that will lie somewhere here. So this will be lower control limit, which is 0.1863. Upper control limit is 0.71, which will be somewhere here. So this is 0.7137, and my mean is so this is 0.40, 0.45. So this will be R bar, which is 0.45. So I will go back and look at the data set again. So the sample 1 is 0.42, so I'll have to plot that. 0.42, so this is 0.4, so 0.42 will be somewhere here. The next one is 0.50, so 0.50 is our sample 2, so that will be somewhere here. And then The third one is 0.41. 0.41, again it will be somewhere here, and then the next one is 0.46. So 0.46 would be somewhere here, and then the next data point is 0.46 again, so that will also be somewhere here, and then finally the last data point would be 0.45, that is on this line. So if you see, again all of them are within the upper control and lower control limit, so R chart is also in control. So if both of them are in control, then the process is in control. If process is in control, if one of them deviates, like if the X bar chart has some data points outside the control limits, then it's not in control. Any one of them, like R chart or X bar chart, if any one of them or both of them have the data points outside the upper control limit and lower control limit, the process is out of control. This concludes my lecture on X bar and R charts. Thank you.